Hello guys, this is the third lecture of compound stress and strain. In this lecture, we will see the third case, which is pure normal stresses on given planes. So what we have here is, we have two perpendicular planes A, B, C, AB and BC, on which stresses are acting, normal stresses are acting. This is sigma y, and here we have sigma x. And now we have to find stresses on this inclined plane, which is at angle theta. Let these stresses be sigma theta and tau theta. We have to find these unknowns. So let's assume coordinate axis, reference axis. Let this be x and let this be y. Now to find out sigma theta and tau theta, what we have to do is sigma fx equal to 0 and summation fy is equal to 0. Now first of all, the area of plane AC is 1. The area of plane BC is equal to sine of theta, and the area of plane AB is cos theta. So let's first do summation fx equal to 0. Here we have one stress sigma tau theta multiplied by its own area, which is 1. So we have force tau theta. Let's convert these stresses into forces. The area of plane BC is sine theta, so this force will be sigma x sine theta, and the area of plane AB is cos theta, so this stress will convert into a force of sigma y cos theta. This angle is theta and this angle is also theta. Now we have one force tau theta in x direction. Then we'll have another component from sigma x sine theta, which will be equal to sigma x sine theta cos theta, and the direction is same as the direction of tau theta was. So we have sigma x sine theta cos of theta. Then we'll have another component from sigma y cos theta, but this will be in opposite direction, so it will be minus sigma y cos theta, and the component will have sine theta term. Okay, and there is no other force here, so this will be equal to 0. So your tau theta value will come out like sigma y minus sigma x sine theta cos theta. This sigma y minus sigma x is written as it is, and sine theta cos theta can be written as sine of 2 theta by 2. So this is your tau theta. Now let's do summation fy equal to 0. In y direction, we have sigma theta multiplied by its own area is 1. Then we have a component of sigma x sine theta, which is equal to sigma x sine theta multiplied by sine theta, but it's in opposite direction of sigma theta. That means it will have a negative sign. So sigma x sine theta multiplied by sine theta. Then we have sigma y cos theta. It will also have a component in the opposite direction of sigma theta. That is why we have minus sigma y cos theta, and it will have a cos component. So this is cos theta, which is equal to 0. Now we have sigma theta and we have sigma x sine square theta plus sigma y cos square theta. Okay, now you have these two values of sigma theta and tau theta. If you see, the maximum value of tau theta will come when sine 2 theta is equal to 1. That means 2 theta is equal to 90 degrees and theta will be equal to 45 degrees. So at theta equal to 45 degrees, you will have maximum shear stress. Okay. Now let's look upon sigma theta. You have sigma theta is equal to sigma x sine square theta plus sigma y cos square theta. So to find out the maximum and minimum values of sigma theta, you can differentiate sigma theta with respect to theta, which is the only variable in this equation, del sigma theta by del theta. So this gives you sigma x sine square theta will become 2 sine theta cos theta, and sigma y and cos square theta will become 2 cos theta and minus sine theta. So this plus will become minus, and you'll have sine theta here. So for maximum and minimum, you have to equate this to 0. This 2 sine theta cos theta will become sine 2 theta, where sigma y minus sigma x equal to 0. So sine 2 theta equal to 0 will give you two values of theta. Theta is equal to 0 degrees and 180 degrees. So let me erase this. So now to check whether you'll get maxima or minima, you have to differentiate sigma theta twice with respect to theta. You have del sigma theta by del theta here, sine 2 theta minus into sigma y minus sigma x. So sigma y minus sigma x will remain as it is. Sine 2 theta will give you cos 2 theta multiplied by 2. So whether this del 2 sigma theta by del theta square is positive or negative will tell you whether theta equal to 0 degree will give maximum or theta equal to 180 degree will give maximum or minimum. So this term will turn positive or negative depending upon the values of sigma y and sigma x. So but you're sure that the maxima or the minima will come at 0 or 180 degree. Okay, so the values of sigma theta at theta equal to 0 degrees will be, the sine theta will goes to 0 and you'll have sigma y, and sigma theta at theta equal to 180 degrees will give you, sorry, this is not for theta, this is for 2 theta. So your theta will have 0 degrees or 90 degrees. So your sigma theta for theta equal to 90 degree will give you sigma x. Okay, so the values of sigma theta will be between sigma x and sigma y. Okay, so from this we have drawn some conclusions. I'll summarize them. In the case where normal stresses are acting upon the perpendicular planes and we have to find stresses on an inclined plane to those planes, we have sigma theta, which is equal to sigma y cos square theta plus sigma x sine square theta. We have tau theta value, which is equal to half of sine 2 theta, sigma y minus sigma x. Then we have sigma theta value ranging from sigma y to sigma x, or sigma x to sigma y, depending upon which one is smaller or which one is bigger. And we have tau theta maximum at 45 degrees with a value tau max equal to sigma y minus sigma x divided by 2. So these are all the conclusions that we have made from this, and we'll take another case in the next class of general two-dimensional stress system. Till then, bye.